we are registered pharmacists. So we have already tackled antibacterials in the past. Almost every subject we have incorporated the mechanism of the discussion of drugs, especially antibacterials. So I know for sure the topics that will be presented is very familiar. So hopefully my goal is we will push that familiarity to expertise, because sometimes we are called the pharmacists are called as the jack of all trades. So masarap pakinggan na you are jack of all trades, but if we are asked or we are confronted with specific conditions or mga circumstances, we don't know the details why and how our drugs behave that way. And we are still expected to answer that. Our doctors, our other practitioners expect the pharmacist to know the details of this drug, not just the mechanism of action or the big umbrella or the big picture of it, but up to the details. So hopefully those familiarity level will be pushed towards the boundary of gaining expertise on this drug. So let's all begin. We were going to have the SAR of antibacterials, or the structure-activity relationship of antibacterials. So first and foremost, our antibacterial is categorized into different types. So one way to categorize it is according to spectrum of activity. So the spectrum of activity can be a broad spectrum antibacterial or narrow spectrum antibacterial. So when you say broad spectrum, the activity of your drug covers a lot of infectious agent across different groups or across different kinds of infectious agents. And if you can recall our microbiology, we have different types of infectious agents, and also in our subject. So we have bacteria, we have virus, fungal, parasites, protozoa. So today we will talk about bacteria. But even we will just focus on bacteria, there is still the classification of broad action against bacteria and narrow action against bacteria, because our bacteria has also a lot of classifications. The main umbrella or the main classification is according to their property under gram staining. So as we have discussed in our subject, the gram staining can differentiate bacteria according to their properties in their cell wall. So we have gram-positive bacteria and gram-negative bacteria. So when we have broad-spectrum antibacterials, it means to say it has the capacity to cover both broad and both gram-negative and gram-positive bacteria, and even beyond this classification, such as mycoplasma type of bacteria and other kind of bacteria. Now, if we talk about narrow spectrum, it means to say it has definite action, or it has targeted action. So it will focus if the drug is narrow spectrum, it focuses only to gram-positive bacteria or gram-negative bacteria. And so much more, meron ding mga antibacteria na very narrow ang kanilang action or very specific. So under gram-positive, there are still a lot of classifications. So some has narrower spectrum that focuses only on cocci, some focuses only on bacilli, some focuses on pseudomonal types, okay? And some focuses on those specific characteristics such as enzyme characteristics. So we will ponder it more later on. Okay? So aside from the spectrum of activity, our antibacterials are classified according to their mechanism of action. So the first is there are antibacterials that can interfere the synthesis of bacterial cell walls, and they have high potential for selective toxicity. So again, you can take this, you can write this on your notes. The first kind of mechanism of action is on the bacteria interfere the synthesis. So we all know if the synthesis is halted or stopped or being modified by the drug, so there will be less or weakened integrity in our cell wall, and that weakened integrity results to easier bursting of our bacterial cell and exposure of the internal environment, or cell lysis. Another kind of mechanism of action is interference with microbial protein synthesis. So they will stop the protein synthesis, or they will delay protein synthesis, mga translation. So that would be resulting to slowing down of bacterial proliferation or bacteriostatic activity. Example for this is aminoglycoside, tetracycline, macrolides, chloramphenicol, and lincomycin. Then we have also nucleic acid synthesis in interference or inhibition. And then we have interference with the integrity of microbial cell membranes for polymyxins and polyenes. So as I have mentioned a while ago, these different kinds of mechanism of action will determine our antibacterial activity, if it's bactericidal or bacteriostatic. Okay, so we will ponder it more according to chemical classification. So aside from the spectrum of activity and mechanism of action, our antibacterials are classified according to chemical classification. So this type of classification is not really presented in the general data for drugs or for general information of drugs. This chemical classification is presented in to us pharmacists, because we are the one expected to understand and to learn these things. So these chemical classification are the reasons why our drug behave like this, why our drug has this kind of mechanism of action. So one common thing that was discovered on chemical classification is the presence of macrolide structure. So there are a lot of drugs that has macrolide structure in their component. For example, a large lactone ring. Another is conjugated cyclic components. So we have conjugated cyclic components of 4 conjugates. We have the family of tetracycline. And then we have also the presence of amino sugar. So these are amines that are glycosidically linked together. So they are called amino sugar or amino sugar moieties. So these are common, or these are the pharmacophores, or the central structure of our streptomycin, kanamycin, neomycin, paromomycin, and gentamicins. And also, we have conjugated polyene compounds. These are very big, very big structures, but these are antifungals. So we are going to discuss antifungals maybe at the last part next meeting, if we have still a time to add more, kasi sa antibacterials tayo nakafocus. So, but just for you to recall, for antifungals, we have polyenes, di ba? So, their compound or their structure has a very big polyene ring. And then we have polypeptides. So they have a lot of peptide chains attached together. This is evident with bacitracins and polymyxins also. And then our very famous penicillin and cephalosporin. So as they are called the beta-lactam antibacterials, because both of them has a central structure called the beta-lactam ring. Okay? So the beta-lactam ring.